Good day, everyone. We are Group 8, and our topic for today is aircraft weight and balance computation. Our group is composed of Richard Kyle Hyde Gaddo, Sydney Anico, and me, Charles Pau, from AMTE 127L 5B, under the instruction of Mr. Jesse Cobilla. In this presentation, we will be discussing how aircraft weight and balance are computed and why it's very important for safe and stable flight. We will go through our activities step by step, including how to calculate total weight, total moment, and center of gravity, and how to analyze this using the aircraft load graph and CG envelope. By the end of discussion, we will understand how proper load distribution affects an aircraft's stability, performance, and overall safety. Before we proceed to the main discussion, here are the objectives of our activity. First, we aim to compute the total weight, total moment, and center of gravity, or CG of the aircraft. Second, we needed to determine the percentage of the mean aerodynamic chord, or Mach. Third, we use the load graph and CG envelope to check if our computed values fall into the allowable operational limits. Fourth, we wanted to understand how improper loading can affect the aircraft's stability and safety. And lastly, we aim to analyze the impact of load distribution on the aircraft performance and flight characteristics.
Good day, everyone. In this part of the presentation, I'll be explaining how we determine the center of gravity, or CG, in terms of percent mean aerodynamic chord, also known as percent Mach. We use the data from the weight and balance table to analyze the aircraft's balance and stability. This calculation helps us identify whether the aircraft is nose heavy or tail heavy, ensuring proper flight control and stability during operation. The table includes weight in pounds, which represents the total load for each part, arm in inches, which measures the distance of each load from a fixed reference point, and moment in pound inches, which is the product of weight times arm. The form used is moment equals weight times arm. From the computed values, we obtain total weight is equal to 2,052 pounds. The total moment is 90,592 pound inches, and the center of gravity is 44.15 inches. Limach, or leading edge of Mach, is 39 inches, and Mach, or mean aerodynamic chord, is 58 inches. Using the formula for percent Mach, we have percent Mach equals CG minus Limach divided by Mach times 100. Substituting the given values, percent Mach equals 44.15 minus 39 divided by 58 times 100. That's 5.15 divided by 58 times 100, giving us 8.88%. This means the aircraft's center of gravity is located at 8.88% of the mean aerodynamic chord. This indicates that the CG is slightly forward, which makes the aircraft more stable during flight. If the percent Mach were higher, the CG would shift toward the tail, making the aircraft tail heavy and harder to control. The result shows that the aircraft's center of gravity is within the safe and stable range for proper flight performance. Good day, everyone. Today I'll be explaining this aircraft weight and balance computation sheet shown in the image. This document is taken from an aircraft weight and balance manual, which helps determine the center of gravity, or CG, of the aircraft. Maintaining proper weight and balance is essential for safe flight performance. It affects stability, control, and the overall efficiency of the aircraft. The table lists different parts of the aircraft and their corresponding. We have the weight in pounds, the arm in inches, which is the distance from the reference datum, and the moment in pound inches, which is the product of weight times arm. Each row represents a component that contributes to the aircraft's total weight and moment. Let's take one example. The pilot. Weight equals 125 pounds. Arm equals 37 inches. So moment equals 125 times 37, which is 4,625 pound inches. The same process is done for all other items, such as the co-pilot, the rear seat, baggage areas, and usable fuel. After computing all components, we sum them up. Total weight equals to 2,052 pounds, while total moment equals 90,594 pound inches. To find aircraft's center of gravity, we divide the total moment by the total weight. So CG equals total moment divided by total weight. That's 90,594 divided by 2,052, which equals to 44.15 inches. This means the center of gravity is located at 44.15 inches from the aircraft's reference datum. The CG location tells us how the aircraft will balance in flight. It must stay with the manufacturer's allowable limits to ensure the aircraft flies safely and efficiently. If the CG is too far forward or too far aft, the aircraft might become unstable or hard to control.
To get all the answers in this aircraft weight and balance activity, we first gathered the necessary data from the aircraft weight and balance manual. We listed all the items such as empty weight, pilot, passenger, baggage, and fuel, along with the corresponding arms. Then we multiplied each weight by each arm to get the moment of each item. After that, we added all the weight and the moment together to get the total weight and the total moment of the aircraft. Next, we divided the total moment by the total weight to find the center of gravity. This gives us the CG value in inches, which presents the balance point in aircraft. We then plotted the total weight and the total moment of the loading graph and CG envelope chart to check if the point falls with the safety operating range. The result shows that the CG was inside the envelope, which means that the aircraft is probably balanced and safe to flight. Finally, we double-checked the plotted line and data to ensure accuracy by using the graph and calculation correctly. We were able to determine that the total weight was 2,698 lbs and the total moment was 39100 lbs in inches, with the CG around 145 inches. This process helped us understanding the importance of weight distribution and proper aircraft loading for flight safety. The aircraft weight and balance table lists all the weight in the airplane and helps calculate the center of gravity. Each item, such as the pilot, co-pilot, passengers, and baggages, affects the aircraft balance and stability. Understanding how each weight contributes to ensures that the aircraft remains with the safe operating limits. We listed all the items that add weight to the aircraft, including the pilot, co-pilot, rear seats, and baggages area. Then we recorded the actual weight of each item in pound and measured its distance in inches from a fixed reference point called the Tatum line. The further the weight in from the Tatum, the greater its effect on the aircraft balance. Afterward, we calculate each moment by multiplying weight by the arm, moment equal weight times arm. We then added all the individual weight to get the total weight, 2,607 pound, and summed up all the moment to get the total moment, 121,665 pound in inches. To find the center of gravity, we divided the total moment by the total weight, CG, equal 121,665 divided by 2,607 equal 46.67 inches. This value represents the point where the aircraft balanced properly. Lastly, using the loading graph, we plotted the total weight and the total moment to check if the CG falls with the safety range. The normal category and utility category areas includes the safe CG limits, while the maximum takeoff weight is 2,550 pounds. Our plotted point fell inside the safety envelope, confirming that the aircraft is correctly loaded and balanced for a safe flight operation.
So, to include our lesson on aircraft weight and balance, this slide shows how important it is to properly compute and maintain an aircraft weight and center of the gravity. Throughout our activities, we learned that even small changes in weight or where the weight is placed can have a big effect on how the aircraft performs and how safe it is to fly. By calculating total weight, moment, and CG, we can evaluate if the aircraft stays within safe limits using tools like the CG envelope and the Mach percentage. These computations help us understand why proper aircraft loading is critical. It keeps the aircraft stable, prevents stalls, and ensures that takeoff and landing are safe. In short, maintaining the CG within the prescribed limits isn't just a technical requirement, it's a major part of keeping every flight smooth, balanced, and safe. And that ends my presentation about aircraft weight and balance computation. Thank you everyone for listening. I hope you learned something new about how weight and balance affect aircraft safety and performance. Once again, thank you.